Today we are going to talk about very important issue, which is earthquake. I think most of you are familiar with earthquake. And the first thing that comes into our mind when we say earthquake, it's mean that we are going to have ground shaking, right? So whenever we say earthquake, it means we are facing ground shaking. The ground itself is going to shake, and as a result, destructive forces will hit our buildings, and it will put all of us in great danger. Today we want to know the source of the earthquake, and I think we had a solid background regarding the earthquake by studying the structural geology. So earthquake is the ground shaking, like we just mentioned, and it's caused by the sudden and rapid movement of one block of rock sliding past each another. And last time we studied the structural geology, and we know that when one block of a rock slide past another block of a rock, it means that we are going to have what's so-called faults. So most earthquakes occur or take place along pre-existing faults. So whenever I have a fault, that means I'm going to have a higher probability for earthquake. And when rocks slide past one another along fractures in the crust, we call this faults. So faults, it means that I have a fracture in the crust. As a result, I'm going to have footman walking, and here I'm going to have the hanging wall. We have the foot wall, and we're going to have the hanging wall, like we just discussed in the crustal deformation. So if I'm going to have sudden movement here along the fracture, as a result, we are going to have earthquake. We want to know the steps in order for the earthquake to take place. We need to know a certain terminology. We are going to start with the focus or the hypocenter. We call that place from which the rock slippage originates in the ground. We are going to call that point hypocenter or the focus. It means that the displacement or the movement is going to start at that point. So the focus is the point from which the displacement or the slippage is going to start. And also we have the epicenter. That point is the epicenter, and that point is directly above the focus. So the point that which is directly above the focus or the hypocenter, we are going to call it epicenter. And when the displacement here start or initiate at that point, the adjacent rocks is going to build up stresses, because maybe this one or that one is going to move, and as a result, the surrounded rocks is going to be subjected to stresses, which means that we are going to build energy. The moment that rock or that rock here passed along the other rock, that means the energy has been released. And as a result, the energy is going to be in the form of seismic waves. So when the energy is released, the energy is going to be in a form of seismic waves. And the seismic wave is going to cause the sudden movement, and that is the earthquake. And the earthquake, it could be from volcanic eruption, or massive landslides, or meteorites. also can generate waves similar to the earthquake. But we need to know that these are usually weak. So the volcanic eruption, the massive landslide, the meteorites can generate earthquake-like waves, like the same thing in the faults. But normally, those movement is weak. Over tens to hundreds of years, stress built up from the plate movement. We already discussed the plate movement. We discussed the convergent, the divergent, and the transformation or the transform. And as a result of that movement, the stress will build up over the time. And eventually, stress along the fault overcomes the frictional resistance. So here, the plates is going to move. In the beginning, we are going to face frictional resistance. And in that time, through the frictional resistance, we are going to build up stress. Because we have forces, one block want to move past another block, but because of the frictional stresses, that movement cannot take place, which means that we have a lot of stresses. And when the stress passes that frictional resistance, then the slip will initiate. And the deformed rocks snap back to their original position in a process called elastic rebound. We are already familiar with the elastic deformation. So to illustrate this, we need to understand the following example here. We know the elastic limit. The elastic limit means when you are applying a force, and when you apply a force, of course, you are going to have deformation. If you release the force, the body or the material, it will get back to its original position. And the rock is like all other solids, are elastic within limits. So the rock is just like the other materials, which means that also the rock has got elastic limit. And this means the rock will stretch or bend when subject to stress. So if we apply stress to the rock will stretch or bend. And if you remove that stress, the rock will snap back to their original position. So assume here I have one piece of rock. And here I have a fault, which means that I have a fracture here. And we are going to call this rock A and this one rock B. Now, if we are going to have movement along the strike line here, which means that the rock here is going to move relative to that rock here, the rock itself is going to be subjected to stress. So now the rock is subjected to stress. We are going to build up stresses. And as you can see, we have deformation here. The rock here is not like the original one because of the stress. So if you have a stick of wood like this one, if you try to bend the stick here like this one, we are going to see deformation. So the shape here is not like the shape here because of the stress. And we have, at that moment, we have resistance. In the rock, we are going to have frictional resistance. When the stress is going to be more than the frictional resistance, what will happen? We are going to see displacement movement. So that rock eventually it will manage to move relative to that one. And here, if I'm holding the stick and I'm applying stresses or bending, then at some point we are going to have a break here. The problem is when the movement took place, the deformation here, it's not going to get to the original location easily. It will go through a process of vibration. So like you can see here, when failure took place here or the fracture took place here, we are going to have vibration. This part and that part are going to vibrate, and then they will get back to their original position. So here, before the break up, we are going to see deformation like this one. When this one managed to move relative to that one, the deformation itself, it will gone. It will get back to its original shape. But before that, we are going to see vibration before the shape is going to restore its original position, like this one. So that plate managed to move from this location to that location, and it's maintained its original shape, like you can see here, without any deformation. But as a result, we got vibration, which is responsible for the seismic wave and responsible for the earthquake. So the strained rock on either side of the fault, here and here, do not stop, snap back and stop. Like a guitar string, after it's plucked, they continue vibrating. So when this one separates from that one, it will not just get back or snap back to its original position with the movement. They will going to vibrate. And that is the result for the earthquake. Another example for that movement, if you are going to hold a block like that, you are going to clamp the rock in this location on the left hand side, and also you are going to clamp it on the right hand side. Then if you apply a force in this direction like that, and in that direction like that, and as a result, the rock is going to bend. And if the rock is going, you see here, the rock is going to bend like this one. And as a result, you are going to see small cracks like this one. If you increase the force, eventually you are going to see new rupture form or new fracture here. And in that moment exactly, we are going to develop seismic wave. And that will cause vibration. So now, eventually, that part released from the stresses, because here, that part was stressed up. When that moment took place, when that part released from the subjected stresses, vibration took place in the form of seismic waves. And this what exactly is going to take place inside the crust. Any questions so far? All of you, do you have any questions up to that point? Okay, let's move on. Also, we have earthquake before the major earthquake, and also we have earthquake after the major earthquake. We are going to have aftershocks and foreshocks. The aftershocks, it means after the major earthquake, we are going to witness a number of small earthquakes. So after we have been hit by a major earthquake, then a number of small earthquakes will take place. And their frequency and intensity is going to decrease by the time. So the amount and the intensity of the aftershock is going to decrease a little bit until it's eventually gone. The problem is the aftershocks is going to destroy the weakened structure. So during the major earthquake, the building is going to be weakened by the major earthquake, but the aftershocks is going to finish the job. It's going to trigger or start the destruction of already weakened structure. That's why aftershocks is very dangerous. And also before the major earthquake, we are going to have a minor earthquake. Sometimes, not all the time. And that is going to precede a major earthquake by days. It could be before days or weeks or even months. We said that the earthquake is going to take place along a fault. It could be new fault or it could be pre-existing fault. The most occurring one is going to take place through the pre-existing faults, but it could take place through the new faults or pre-existing fault. And of course, in order to have that, differential stresses will be present. And like you already know, the fault, it could be normal, and that it's associated with the divergent plate boundaries. If it's divergent, that means we are going to have which type of stresses? Is it tensional stresses or compressional stresses? Which
tensional.
One? Tensional. And we need to know that normal is not associated with a large earthquake. So if I'm going to have normal fault, I'm going to expect that the magnitude of the earthquake is not going to be large. The other types, which is the reverse and the thrust, we know that there is a difference between the reverse and the thrust. Anyone can remember the difference between the reverse and the thrust faults?
The thrust is less than 45 angle degree, and the reverse is more than 45.
Yes, it's very good. And the reverse and the thrust are associated with the convergent plate boundaries. And in this case, we are going to have which type of stresses? Is it tensional stresses or compressional stresses?
Compressional stresses.
Yes, very good again. And in the subduction zone, the boundary form what's so-called Megathrust fault. And this one produce most of the Earth's powerful earthquake. And also it could be generate tsunamis. So the Megathrust fault is very dangerous type of fault. It's going to produce powerful earthquake. And also we have the strike slip. Strike slip means the movement is going to be along the strike direction. And this one is associated with transform blade boundaries. And the gradual displacement called fault creep. And rupture result in major earthquake. So here we have many figures for different type of faults. The first one here, which one do you think this one is a type of fault?
Normal.
This one is a normal. Why you say this one is a normal?
Because we have tension stress and we have the hanging wall is above the line of fracture.
And the hanging wall is moved down relative to the foot wall block.
Yes.
What about this one? This one here. Which type of fault? It's
This is a
reverse.
reverse, yes.
What about why did you say this one is a reverse?
Because
Unfortunately,
the hanging wall moving uh, up a foot wall block.
So this one, which is the hanging wall block, is going to move up relative to the footwall block. What about that one here?
thrust.
Thrust.
Why this one is a thrust?
Reverse with an angle less than 45.
Yes, excellent. What about that one here? The last figure.
Strike slip faults.
Why?
Because we have shear stresses and we have a movement relative to each other.
Yes, which means that the movement along the strike direction.
Yes.
Here in this figure, we are going to see the result of the earthquake or the fault. So the fence here used to be connected with that one. But as you can see, now we can see a separation between them about 2.5 meters between the fence in the left-hand side and the fence in the right-hand side. And that because, which type of fault do you think? Your opinion.
Strike slip.
Strike slip. Because this one is going to be the strike direction and the displacement is going to take place along that line. Also in this figure, we used to grow a trees or put the trees in a straight line. But at that line here, like you can see, the trees has shifted a few meters away from that line. It means that we are going to have, or it means that the strike slip took place in that direction. And as a result, the trees now are not in straight lines. So we could witness phenomena for a different type of faults. And here we have the Megathrust fault. It says that the Megathrust fault is one of the most powerful earthquake. And it will take place at the subducting plate. We already discussed this one before. So at that region here, we are going to witness a powerful earthquake because we are going to have Megathrust fault. Also in these places, we are going to witness thrust faults. Because if you take this one as example, this one will represent the hanging wall, and this one will represent the foot wall. And the hanging wall is going to move relative to the foot wall. And the angle here, if it's less than 45, then we are going to consider this thrust fault, and this one also thrust fault, and all of them. You can say this one here, it could be reverse because the angle is more than 45. And here also we can see the strike slip fault. The displacement is going to take place along the strike direction. And of course, this one is the famous city or the famous state in the United States of America, California. And this one is the famous San Andreas fault. And this one is responsible for the earthquake in the California. Like you can see here in the San Andreas fault, we are going to witness a lot of relative movement. And many rivers is going to change their direction because of the San Andreas fault. Because the branches, the distance between the branches is going to be shifted. And finally, we need to know that the earthquake is not to take place all of a sudden. It's going to go through steps. The slippage or the displacement movement, it will go through many steps before we see the earthquake. First, like you can see in this picture here, if this one is the hypocenter, we already defined the hypocenter by the point where the slippage is going to start. And this one is the fault. This one is a fault. This one is going to represent the hanging, and this one represent the foot. And this one is the rupture surface. So the movement is going to take place within that surface here. And the displacement, it will initiate or start at that point, at the hypocenter. Then the movement is going to propagate through the rupture surface. So the propagation of the displacement is going to be along the rupture surface. So in the next figure here, we can see that the movement is going to be bigger and bigger, but within the rupture surface. Now, that movement is going to be resisted by the capacity of the rock itself. If that movement is managed to be more than the frictional resistance between the hanging and the foot, in that place, this part is going to move relative to that part. And here I can see, or I can measure the movement. So in that figure, the stress is going to build up, and we are going to see deformation. When that stress exceeds the frictional resistance, then that part or that block is going to move relative to that block. And here we can see the displacement. And as a result, the seismic wave, it will spread out, and those who living on the surface of the earth who are going to witness, or they are going to see sudden movement, even though we have steps before that sudden movement. So next time, we are going to talk about seismology, which is the study of the earthquake waves. We have many types of waves. We are going to classify them, but that will be next time. Now, do you have any questions regarding how the fault is going to propagate, or do you have any questions about the type of the faults? Now I'm going to leave the floor for you to ask questions.